constraint and statistical determinacy. The equilibrium equations developed in this article are both necessary and sufficient conditions to establish the equilibrium of a body. However, they do not necessarily provide all the information required to calculate all the unknown forces which may act on a body in equilibrium. Whether the equations are adequate to determine all the unknown depends on the characteristics of the constraint against possible movement of the body provided by the supports. By constraint, we mean the restriction of movement. In the example 4 of previous figure, consider this picture, a roller ball. Consider this picture for an example. In this example, ball and rocket provide constraint normal to the surface of contact. Provide constraint normal to the surface of contact. But more tangent to the surface. Non-tangent thus a tangential force cannot be supported. For the color and the slider of example 5, constraint exists only normal to the guide. In this picture, for example, in the sliding example, constraint exists only normal to the guide. In the example 6, the fixed pin constraint only is normal, and the next example is different. In example 6, the fixed pin connection provides constraint in both directions. P X and Y direction. But offers no resistance to rotation about the pin unless the pin is not free to the third. The fixed support of example 7, consider this example, a fixed support. A fixed support, however, offers constraint against rotation as well as lateral movement. If the rocker which supports the truss of example 1 were replaced by a pin joint at point A, consider this picture. If the rocker which supports the truss of example 1 in this picture were replaced by a pin joint at point A, this rocker, replace it with the same pin here. There would be one additional constraint beyond those requirements support, so after this change a force will be added here, for example bx, so a constraint will be added to the constraint beyond this required to support an equilibrium configuration with no freedom of movement. The three scalar condition of equilibrium in this equation will now provide sufficient information to determine all forces, all four unknown, since ax, bx could not be solved for separately. In this case, we have three equations. But four unknown, ax, bx, ay, and by. In this case, these two components of force would be dependent on the deformation of the member of the truss as influenced by their corresponding stiffness properties. The horizontal reaction AX and BX would also depend on any initial deformation required to fit the dimension of the structure to those of the foundation between A and B. Thus, we cannot determine the AX and BX by a rigid body analysis. Again, referring to this picture, we see that if the pin B in the example 3, consider this example, if the pin B in this example were not free to turn, after that we should add an M here, B replaced to fixed joint. When not free to, the support could transmit the couple to the beam through the pin. Therefore, there would be four unknown. In this case also we have three and four unknown. A X, AX, AY, and M, B. Therefore, there would be four unknown supporting reaction acting on the beam, namely the force at A, the two components of force at B, and the couple at B as I write here. Consequently, the three independent scalar equation of equilibrium would not provide enough information to compute all four unknowns. A rigid body or rigid combination of elements treated as a single body, which poses more external support or constraints that are necessary to maintain an equilibrium position, is called statically indeterminate. Let me take note. According to example, a rigid body so we can write a definition for a statical indeterminate condition, a rigid body or origin combination of elements treated as a single body which possess more external support or constraints than are necessary to maintain an equilibrium position is called statically indeterminate. Supports which can be removed without destroying the equilibrium condition of the body are said to be redundant. Without destroying the equilibrium condition of the body are said to be redundant. The number of redundant supporting elements represents the corresponding degree of statistical indeterminacy the number of redundant supports is equal to degree of statistical indeterminacy. And equal to the total number of unknown external forces. Minus the number of available independent equations minus the number of available equations of equilibrium. On the other hand, bodies which are supported by the minimum number of constraints necessary to ensure an equilibrium configuration are called statically determinate, and for such bodies the equilibrium equations are sufficient to determine the unknown external forces. The problems on equilibrium in this article and throughout the static are generally restricted to statically determinate bodies where the constraints are just sufficient to ensure a stable equilibrium configuration and where the unknown supporting forces can be completely determined by the available independent equation of equilibrium. We must be aware of the nature of constraints before we attempt to solve an equilibrium problem. A body can be recognized as statically indeterminate when there are more unknown external reactions than there are available independent equilibrium equations for the force systems involved. It is always well to count the number of unknown variables on a given body and to be certain that an equal number of independent equations can be written. Otherwise, efforts may be wasted in attempting an impossible solution with the aid of equilibrium equation only. The unknown variable may be force, coupled distance, or angles. Adequacy of constraints is the next section.